Hello everyone, my name is Shreyas Sar Kumar and I am from Sri Venkateshwara College of Engineering. I am currently studying in the third semester on the Department of Data Science. And today my topic is two-way ANOVA. So let's begin with what two-way ANOVA is. Two-way ANOVA is a statistical method used to analyze the effects of two categorical independent variables on a continuous dependent variable. It allows us to determine whether there are interactions between the two independent variables and their individual effects on the dependent variable. Two-way ANOVA is a powerful tool for researchers to understand the relationship between multiple factors and the outcome of the interest. So let's see the assumptions in two-way ANOVA. The data should be normally distributed within each combination of two independent variables. The variances of the dependent variable should be equal across all combinations of the independent variables. The observations should be independent of each other. So let's see the hypothesis in two-way ANOVA. The null hypothesis is a two-way ANOVA that states that there are no significant effects of either of the independent variables or their interaction on the dependent variable. The alternative hypothesis possesses that at least one of the independent variables or their interaction has a significant effect on the dependent variable. Two-way ANOVA allows us to test multiple hypotheses simultaneously and determine the significance of each factor. The null hypothesis is a two-way ANOVA. The null hypothesis in a two-way ANOVA are these. The population means for the DV are equal across levels of the first factor. The population means for the DV are equal across levels of the second factor. The effects of the first and second factors on the DV are independent of one another. Calculating the F statistic in two-way ANOVA. The F statistic in two-way ANOVA is calculated by dividing the mean square of the main effects or interaction by the mean square or the error term. The F statistic follows an F distribution and is used to determine the statistical significance of the effects of the independent variables and their interaction. A significant F statistic indicates that at least one of the factors has a significant effect on the dependent variable. Now let's see interpreting two-way ANOVA results on how to interpret them. When conducting a two-way ANOVA, we look up at the p-values associated with the main effects and the interaction term. A significant p-value for a main effect indicates that the corresponding independent variable has a significant effect on the dependent variable. A significant p-value for the interaction term suggests that there is a significant interaction effect between the two independent variables, as we can see in the given diagram. Now let's see the post hoc results in two-way ANOVA. If the results of a two-way ANOVA are significant, post hoc tests can be conducted to determine which specific groups differ from each other. Common post hoc tests include Tukey's HST, Bonferroni, and Schaeffer tests. Post hoc tests help to just identify the specific differences between groups and contribute to the overall significance of the two-way ANOVA results. Your SPSS output for two-way ANOVA. Sex of respondent has a significant main effect on hours per day spent watching TV. Home ownership has a significant main effect on hours per day spent watching TV. Gender of respondent and home ownership have a significant interaction effect on hours per day. spent watching TV. Now let's see the advantages of two-way ANOVA. Two-way ANOVA allows researchers to investigate the effects of multiple factors on a dependent variable simultaneously. It can identify interactions between independent variables that may not be apparent when analyzing each factor individually. Two-way ANOVA provides a comprehensive analysis of the relationships between variables and their impact on the outcome of the interests. Now let's see some formulas in two-way ANOVA. Sources of variation, sum of squares, degrees of freedom, mean, sum of square, and F ratio. For between the columns, SS is sigma of Ti square divided by Ni. Degree of freedom is C minus 1, and Ms is SS between columns divided by C minus 1, and the F ratio is Ms between columns divided by Ms residual. Between rows, the SS is sigma of Ti square divided by Ni. Degrees of freedom is given by R minus 1. Ms is equal to SS between rows divided by R minus 1. The F ratio is given by Ms between rows divided by Ms residual. Residual error. SS is given by SS between columns and SS between rows, which is subtracted from total SS. The degrees of freedom is given by C minus 1 into R minus 1, and the MS is given by SS residual divided by C minus 1 into R minus 1. The total is given by sigma of xij whole square minus t square divided by n, and the degrees of freedom is given by C into R minus 1. Limitations of two-way ANOVA. The limitations of the two-way ANOVA are as follows. Two-way ANOVA assumes that the data meets certain assumptions, such as normality and homogeneity of variances. It may be challenging to interpret interactions between independent variables if they are complex or difficult to measure. Two-way ANOVA can be sensitive to outliers or violations of the underlying assumptions, which may affect the validity of the results. Now let's see the practical applications of two-way ANOVA. Two-way ANOVA is commonly used in experimental research to analyze the effects of multiple factors on a continuous outcome. It is frequently employed in fields such as psychology, biology, and social sciences to study complex relationships between variables. Two-way ANOVA can help researchers identify significant factors that influence the outcome of interest and guide further investigations. Now, I would like to conclude this video by saying two-way ANOVA is a valuable statistical tool for analyzing the effects of multiple categorical independent variables on a continuous dependent variable. By testing for main effects and interactions, researchers can gain insights into the relationships between variables and their impact on the outcome of interest. Understanding the principles of two-way ANOVA and its applications can enhance the rigor and validity of research studies across various disciplines. Thank you. If you have enjoyed watching this video, like and share it, and subscribe to the channel for more content like this.